Good afternoon, ladies and gentlemen. Today, I would like to talk about going green with alternative-powered engines. I am Yeong-Ho Kim from KR. Thank you for inviting me to this conference. There are many regulatory issues surrounding the industry. I would not, however, focus on regulations, but I would like to talk about what kind of activities are going on regarding the alternative engines. First, if you look at the top middle graph and the graph on the left side, you can see that there's a growing amount of carbon accumulated on the Earth, and the Earth's temperature is gradually growing. Even without looking at the graph, you will know already that the global warming is speeding up and the Earth's temperature increase is also being accelerated. On the top right side, you see another graph. This year in summer, it was very hot in Korea. From June till August of 2023, this is the level of temperature across the world. In June 2023, June has the highest level of temperature in history. If the current trend continues, then the average temperature increase of 1.5 Celsius degree will happen in December 2034. Of course, we will see what happens when we reach 2034, but based on the data we have now, we expect that the 1.5 Celsius degree will be realized in December 2034. This is why many countries across the world are taking various measures and proposing targets to prevent such a temperature increase. Let's have a look at the maritime industry. There are international regulations put by IMO. There are regional regulations by, for example, EU and the US. As you see here, EEDI and EEXI are already being applied to the industry. And from May 2027, the data collection system and LCA guidelines will be applied. Specific methods of implementation is under discussion, but 2027 will be a very critical period of time in terms of compliance with the regulation. And EU ETS, Fuel EU Maritime are going to be the very important regulations we have to consider. And the US has similar regulations announced. EU and US are leading the regulatory changes, which will be followed by other regions and countries across the world. Then EU MRV data is here to compare energy efficiency of various fuels. The data after 2023 was predicted based on the data we have as of 2022. If the situation of 2022 continues, then grade C will take up around 70%. And if we continue our current way of operation, the number of vessels with efficiency of grade C or higher will dramatically decrease. You may take your own operational improvement measures, but first of all, you have to consider how to change your fuels. For now, LNG and biodiesel are being discussed as alternatives. And in the far future, green fuels will be used more to achieve energy efficiency level of grade C or higher, and to also meet the GHG reduction targets. Then let's have a look at the propulsion sector. In order to achieve the GHG reduction, these activities are being carried out in propulsion sector. First of all, this is the Clarkson's data. This diagram was announced by Clarkson in October 2023. Except for LNG, these are the alternative fuels expected to be adopted to the vessels. Based on GT, 38% will be taken up by alternative fuels, and LNG takes up 67% and methanol 25%. So far, LNG and methanol are the main options, main alternative fuels. Recently, an order was placed for ammonia vessel. Then, in order to make a good choice of the alternative fuels, there are key considerations. First, we have to reduce emissions, we have to reduce penalties, and we have to see if these alternative fuel technologies are stable technologies and future-proof technologies. We have to look at infrastructure challenges and the amount of fuel supply. We have to also consider the ship design changes and engine availability. We have to consider these points when we adopt alternative fuels. Biodiesel is the easiest one. There are issues like viscosity and micro growth in fuel, but biodiesel is the easiest alternative fuel we can use now. And regarding the use of biodiesel, all stakeholders say that they can accept biodiesel. But if you look at the footnote below there are some comments that if you use biodiesel, lifetime of components could be reduced. But it is true that we can use engines continuously when we adopt biodiesel. And GS Cartex also is going through a demonstration project to use biodiesel on the vessels. And two-stroke DF engines can be adopted by vessels. On the right side, you see different configurations, different types of engines, beginning from LNG, methanol, and LPG, and ammonia, and someday hydrogen. These fuels can be employed by the two-stroke DF engines. For now, methanol and ammonia have received the highest level of attention because their fuel supply system could be similar to biodiesel because they can be supplied in the form of liquid. So the existing crew and seafarers would feel familiar with using methanol or ammonia. Of course, we have to consider the properties and characteristics of methanol and ammonia, so we have to consider safety issues, but basically, the basic concept of using methanol and ammonia are similar to the concept of using diesel. If we choose to use LNG DF methane sleep is a very essential issue we have to discuss. If you look at MEPC 80 meeting minutes and Fuel EU Maritime Annex 2, they described the specific figures for LNG methane sleep. On the right side, for different types of LNG engine, you can see that there would be methane slip. Currently, regulatory discussion is going on, and you have to calculate the cost you may have to spend. And if the methane slip increases, you will have to spend more regulatory cost. For example, if you calculate the methane slip to the amount of CO2, that will stand at around 2 to 3% of increase in terms of the cost. So you will have to spend more regulatory cost if you have methane slip. And GWP 100 reference is here in the table. Each country has different levels of GWP 100 reference. So it depends on the regulation. engine manufacturers also understand the situation, and many of the engine manufacturers are saying that we have reduced the level of methane slip by using, for example, EGR. So we have to address the issue of methane slip. And it's not that all vessels will be able to use alternative fuel. According to the table here, you will see that vessels over 70,000 DWT and vessels with over 10,000 kilowatt power will be able to use alternative fuels. It also depends on the ship design, how the ship is manufactured, built by the shipyards. Depending on the ship size and engine power, they will be able to use alternative fuel or not. Then let's have a look at timeline. LNG has already been commercialized, but it took for about 10 years for us to commercialize LNG. For green methanol, it'll take from 3 to 5 years. If the methanol is produced or the ammonia is based on hydrogen, that it'll take from 5 to 10 years for commercialization. And have a look at the graph on the right side for green methanol. By 2028, this is the amount of fuel needed for the methanol. As you see, as time goes up until 2028, the demand for methanol will significantly increase, and by 2028, we guess that methanol bunkering infrastructure will be further developed to meet the demand. And when will be the time when the green methanol and ammonia will have the similar level of needs and demands? It will be around 2030. By around 2030, the proportion of green methanol and ammonia in the market will increase further, and even if you install the relevant engine on the vessel, it does not mean that you can use alternative fuel right away, because you have to address many issues. In the case of LNG, there are mechanical issues we have to consider. As you might have experienced, LNG gives some impact on the nozzle. Also, you have to deal with some residual heat issues as well. For now, design has been improved and field testing has been conducted, and many issues have been solved. Methanol gives us similar issues, so you need to place shield like this, or if you operate the vessels with diesel mode for about 2 months, then you have to replace the existing methanol nozzle with a dummy nozzle. And mechanical issues are supposed to appear if we use DF engine with ammonia or methanol. So the ship operators, ship designers, and other relevant parties need to discuss with each other about how to address the issues, including mechanical issues. And the size of the nozzle that will be installed in the Maersk vessel is this size. This is a very big nozzle. In order to conduct repair and maintenance on the nozzle, you have to use a crane. So in order to carry the nozzle and in order to transport them to the maintenance site, you have to use a crane, or you will need to extend a rail to safely carry them to their maintenance site. Methanol and LNG are considered clean fuel, and many people think that the filter will not be clogged. But if you look at the picture here, in LNG and many alternative fuel lines, clogging could be created, and that will delay the operation or testings. So before commissioning the engine, you have to look at the filter, or you can install some jigs or equipment to prevent clogging of the filter. And methanol, LNG, and ammonia fueled vessels will be using the engines controlled by the electronic or the system. So software will become very important. There are concerns about using software for the engine, but you may experience unexpected situation while operating the ships. Then you will have to update the software and reflect the feedback from the site. And shipping companies that receive the initially developed software and engines are highly likely to experience various engine issues, including software issues. And when we use alternative fuel engine, we have to be aware of the possible leakage. If such a leakage takes place, a fire could take place, or in worst case, human life could be taken by such incident. So we have to make it sure that crew and the seafarers are able to respond to the leakage problem or accidents. And many new functions are being applied to the engines, not just EGR, SCR, and another new method has been created to put water in methanol, for example. But while applying these new functions, we might experience errors, trials and errors, and it'll take time for us to solve all these problems. So it's important that shipyards, shipping companies, and ship operators need to share information about their experience with the new functions. Another important aspect is training. There are statutory or mandatory trainings and practical trainings provided by engine companies. We have to receive such trainings. In the case of mandatory trainings, crew members must receive the training required to deal with the alternative fuels, and practical trainings provided by engine companies are also useful for crews and seafarers to prevent any problems. And shipping companies, for shipping companies who will make efforts to achieve the GHG target, we are helping them. We help them identify the energy efficiency of their vessels and work on the design issues as well. For each step, so you need to take a step-by-step approach. You also need to set ESG strategies to respond to the upcoming GHG reduction issues. In summary, we are going through climate crisis and the earth temperature is rising. Many countries are announcing their own regulations to reduce GHG, and manufacturers are doing their best to comply with such regulations. And biofuel, including LNG, methanol, and ammonia, and DF engine portfolio are also increasing and are widening. And there are many issues we have to address. So many interested parties or stakeholders need to share all those issues together. And KR recommends that you have to establish your own ESG plans and strategies for net zero goals. And we are open to your request and your request for support. Thank you very much for your attention.